Hello all, welcome to a project Imply Promotion Evaluation with automated machine learning. So the main aim of this project is to predict whether an employee should be promoted or not using automated machine learning techniques. So now let us understand the data a little bit, that what is the motivation behind it. Basically this data is taken from a Kaggle website, and this problem statement was given which stated as the HR team stored data of promotion cycle last year, which consists of details of all the employees in the companies working last year and also if they got promoted or not. But every time this process gets delayed due to so many details available for each employee, it gets difficult to compare and decide. Basically, the problem statement says that there was a company in which the HR team was there and they were finding very difficult to decide to who to promote or not because of the abundant data present for them for the process to process the information. So this is where we come in. We'll try to build a machine learning model which will help the HR team so that they can easily select okay which promotion, which person which should be promoted or not. So let us understand the problem statement for a bit, that we are given a data set in which various attributes are given which will help us in predicting what is the performance of an employee and if he should be promoted or not. Using this data we'll build a machine learning model. Okay, so this was the, I have already told you the problem statement, this was the answer. Okay, how we'll proceed towards it. Okay, so I said that we'll be using automated ML, but what is auto ML? Automated machine learning or auto ML is the process of automating the task of applied machine learning to real world problems. Basically, automated machine learning automizes the model development part. Now, what model development is? All of these things, the model building, model hypertuning, model validation, model selection, all of these things comes under model development part. So AutoML automates all of these things. So now in this we'll be using Eval ML library. There are various libraries, AutoML libraries, but we'll be using Eval ML for this project. So what Eval ML is? Eval ML is an open source AutoML library written in Python that automates a large part of the machine learning process, and we can easily evaluate which machine learning pipeline works better for the given set of data. Okay, so this is Eval ML, and this is a pretty popular library, and we'll be seeing these different aspects of it in the further sections. So proceeding to the timeline of the project, the very first thing which we'll be doing will be data analysis, seeing our data, visualizing our data, then feature engineering, data pre-processing, basically making our data ready for model development. Then we'll build our model using ML algorithms. Then we'll use the auto ML, that is Eval ML library, compare both of them and see which performs better and what is the difference between them. So all of these things will be performed in this project in the upcoming sections. Let's begin. Hello all, welcome to a project notebook project employee evaluation for promotion using ML and Eval AutoML. So now previously in the introduction section I have already introduced to the context, okay, what was the problem statement given in the Kaggle website, that the HR team was finding it very difficult to see that which employee should be promoted or not due to the abundance amount of data. So we'll be building a machine learning model. We'll build a model from stored data that will predict if a person is eligible for promotion or not. So I've told you that the timeline of the project, that first we'll be importing libraries and data set, we'll be doing data analysis, feature engineering and data pre-processing, and we'll build model using ML algorithms, then auto ML, that is the Eval ML library. So now the very first thing is that we'll import the libraries. We'll importing pandas, numpy, cpon and matplotlib for visualization, label encoder, train test spread for data pre-processing, and pandas, numpy also for data pre-processing and other techniques. So now the very first thing is we have to read the dataset. So in order to read the dataset in Google Colab, you first have to import your dataset into a drive. Then you have to mount your drive. You can mount your drive by clicking this button here. This command will open. You have to execute it. So where the first you have to upload your file in that drive which you have to mount. Okay, you just have to authorize this link, authorize Google Colab to access the data. It will give you an authorization link. Go here, paste this link here. It will take a 10 to 15 seconds to get mounted. The drive will get mounted. Okay, as you can see, it is saying mounted at content drive. So now all of the data is mounted in my Google Colab environment. If I see, this is my drive and all of these things are present. I have already uploaded my CSV file in my drive, this drive. All I have to do is find that file named employee promotion. This is my file. I'll just copy the path and I'll read it using pandas by pasting the path here. Simple. I have redid my data under my column df, then I'll see my data. Okay, so this is my data. So this is a very data provided by the company, in which various number of things are there. The employee ID, what is the department, what is the region, if it's what is the education of that person, what is the gender, recruitment channel, number of trainings, age, previous year rating, length of service, awards won, average training score, and finally is promoted or not. This is basically the sample train data. So this is how these are all, I think all these things are sufficient to say okay which model, which person should be promoted or not. So we'll be doing this with the help of machine learning things, but first we'll be analyzing and pre-processing things. Okay, so we'll be doing that, in the further sections. So let's proceed. Hello all, welcome back to our project section. In this section we'll be doing the data analysis and pre-processing part. So now in the previous section we saw the introduction of the problem, then we saw that how we can import our data so into the Google Drive. So this is our data. We have already seen what are the different criteria for that. So now the first thing we'll do is we'll just see what are the data types. So this is showing all of the data types. Some of them are integer, some of them are object type, some of them are float. Then we can also see the describe. We can see that then it will describe all of the data, all of the numerical data into the, it will give us the numerical analysis of the integer data. Okay, so employee ID, number of trainings, age. We can see that, okay, count is around 54,808, which means that there are around 54,000 of records. And we can see that age, the mean age is 34, which means that average person is around of 34 age, maximum age around 60, 50 percentile is 33, and all of these things. Previous year ratings, length of service, the maximum amount of service length is 37 years of service. Awards won, if it has awards won or not, average training score, all of these things. Okay, so now we will be doing data analysis and pre-processing. So and the very first thing which comes in our mind is the null values, right? So first let us see that if there are any null values or not. So yes, there are some in education, previous year rating, and average training score. So now what we'll do, we'll drop these activities, because as we see that there are 54,000 records. So if we'll drop some of them, it will not create much impact. I am dropping these for the sake of simplicity, but you can do this, but you can actually deal with them by mean median mode imputation or sample imputation, any of the method. Education you can write with the sample imputation, or the which sample, which education is the most, you can add these. For previous re-rating you can add median imputation, average training score, also mean median mode, any of the imputation you can write, but I have not done that for the sake of simplicity. So now the very first thing is the employee ID. We don't want employee ID, right? What is the purpose of employee ID in seeing that if it will be promoted or not? So we'll just drop the employee ID. Okay, so now we have this data, so we don't need to drop any of other things right now. So now the very first thing which we'll do is we will divide our features. The one in continuous feature, numerical features, and we'll divide categorical features. For numerical features, I am saying that okay, I in df dot columns. If data types is not equal to object, these are all numerical features. So these are our numerical features: number of training, age, previous year rating, length of service, all of these things. The same goes for categorical features. If the data type is for object, then these are our categorical features: department, region, education, gender, recruitment channel. Okay, so now we'll just visualize our data. I am saying that in numerical features, if you want to visualize a numerical feature, the best thing is to do is to apply a box plot. When I apply a box plot, it will give us me the outliers and all of the things present. So as you can see, the age is having a lot of outliers, previous year ratings, length of service is having a lot of outliers, because there will be a very few of the people which will be serving a lot more, okay, greater than 10 years, because in length of service the approx is 5 to 7 years. Okay, most of the people leave the company or move to another. There are only some people who continue in the same company for a long amount of time. They are usually the bosses of the company. So now this next thing we'll do is we'll just plot a pie chart. In that we'll see what is the distribution of features. Okay, in that I'm just using a simple command. I'm saying okay, for feature in all the df columns, I'm saying okay, give me the value count of all of these and see that how are these features distributed. For the first feature, I am see that okay, how is that, what is the department? As you can see, sales and marketing is the maximum, operation second, followed by technology and procurement. Then the second one is the region, then this is the education, masters and above, below secondary, and the bachelor's is the maximum. Gender, as you can see, male is the maximum and female is around 30%, 70-30 ratio is there. Then all of these things. Okay, so some of age is around, age is properly distributed, which means in that 32 to 36 are in abundance. Mostly 50% of the things are contributed by 30 to 36 age group. And then the another thing is previous year rating. For 3 is the maximum, then followed by the least is the 2. If I am saying is promoted or not, in that it is saying that around 91% of the people were not promoted, 8% were, 9% were promoted. Obviously that competition is quite tough in a company, that's why. Then the another thing is awards won, to around only 1% of people have won award. Obviously the award would have won by a very less people. Then age training score, average training score is quietly distributed. We cannot understand much about it because it is constantly distributed. Then the length of service is also around 2 to 5 years in 2 to 7 years in abundant, consisting around 65% of the data. If we'll consider to 6, then it will consist around 70% of the data. Okay, so now this was the certain analysis how different features were distributed. Now we'll again plot a distribution plot on the number of on basically the numerical columns. Okay, on basically the numerical columns, we'll see that okay, how these features are distributed. So when we'll see the number of trainings, age, the same information is provided here. This is provided in the pie chart form, this is provided into a distribution plot. Basically both, it depends on the person which one he likes, but basically personally to me, I like the pie chart representation because it is more appealing and I can understand more from it. But in the distribution feature also, I can exactly see the density and I can see what, how my data is distributed. If it is distributed normally, it is left skewed, or if it is right skewed. So this is the advantage of distribution plot. So now the another thing we can do is we can plot a QQ plot. Basically QQ plot is a combination of a probability plot and a distribution plot. So it will tell us okay, if my features are normally distributed or not. So I'll just plot a function. In that I'll import stats and pylab, then I'll say plot a figure. In that plot two, in the first figure subplot, plot a histogram. In second figure, plot a probability plot. Then I'm writing a for loop for feature in my columns. My columns are these, the numerical features. And I'm saying okay, plot a QQ plot so that I can see how these features are distributed or not. So as you can see, these, it is not that much normally distributed. They are deviating from the line. If they were in the line, that means it is distributed, but these are not, these are categorical, these are not distributed very good. Okay, so we'll do some of these things about it. What we can do is we can do a log transformation. Okay, we can, there are various several transformation, log transformation, and reciprocal transformation, square transformation, but I am doing here log transformation. What I'll do, I'll just use the log values. I'll just convert these values and take log of all of these values. I'm taking what, I am taking age, I am taking service, and I am taking score. I'm taking okay, take all those logs and insert that things in my df value. Okay, so new columns are created: age log, average training log, and all of the another one, the score log. Okay, these three columns are created. Then I am again I'll again just plot ke how are these distributed. Okay, I'll plot the distribution for these in the log plot. Now you can see that this is my distribution of age after taking the log. Okay, now as you can see, what the huge distribution has occurred, they have shrinked to a particular value. When we see, if we'll see the age distribution plot, so now as you can see, how is this distributed, right? And then if we'll see this, it is up more normally distributed, it is more correctly distributed, right? So now we can also plot a QQ plot for this, and we'll see that if it is falling in a line. So now as you can see, it is most probably falling in line. Okay, this is also in line, this is also in line. This does not work well for the initial data, because so we can do a one more transformation. For that you can do it as an assignment, you can take it as an assignment and do it. You can do either reciprocal transformation or square transformation to see that if that works or not. Okay, so we can transform the data and we try to make it as normally distributed as possible, because that is good for our model. So the next thing which we'll be doing is we'll be plotting an heat map. We'll be doing some one hot encoding and scaling our data, splitting our data. That we'll be doing in the next section of this next part of this section. So let's proceed to the next section. Hello all, welcome to the next part of our data analysis and pre-processing. In the previous sections, we saw that how we can import the data when we see some did some data analysis and we transformed our data. We see that how our data is normally distributed or not. If not, how we can make this. We perform log transformation. We saw distribution plots for all of these. So now the next thing we'll be doing is we'll be plotting a heat map. We'll be plotting a heat map. Basically, a heat map is a visual representation of a correlation matrix. This basically tells us how the things are correlated. So this is a very wonderful representation of correlation. We can see with the color schemes only that which data is highly correlated, and we can see that age log and number of service log are highly correlated, and similarly age log and length of service highly correlated, and the length of service log is highly correlated because obviously that is a log form of that. Then all of these things, okay, so we can see this on the basis of this color only. Okay, on the basis of this color we basically see, we one thing we found out that no one of this is negatively correlated, because this is why this is happening, because the things which the data we have given are all positive data. Okay, these are all the attributes which tells us that okay, if this value should be promoted or not. So many of the things are positively correlated only. So this gives us an understanding of how this data are correlated in a very wonderful color scheme. Okay, so now we have done with the data analysis part, so and the log transformation part. Then the next thing we have to do is we'll be doing the one hot encoding. One hot encoding, which it is basically getting me the dummies of all of these things. Basically it will give me the dummies equal to the number of categories. It will tell us that if my department, for suppose department, if my department is analytics, then it will provide a 1 in that column. If not, it will provide you a 0. For that, in the first row my department is sales and marketing, that's why it is 1. The rest of all is 0. That is how the different categories of variables are created. Now if we'll just see our shape, df encoded dot shape. So around 61 columns are done. Okay, 61 columns, 46,000 because we dropped the null values. 61 because of the one but dummy variables which are created, which were around 51 new dummy variables are created because previously we had 10 variables. So now the next thing which we'll do, we'll scale our data. As you can see, we'll scale our data a little so that all of these things remain in a particular small format. I'll just and to use the standard scaler, I'll say okay, scale dot fit, all of my data is scaled between -1 to 1. Okay, so I'll just use, it's a very simple command. In that I use standard scaler fit all the df encoded feature. I provided the feature into a stored them into an array. Then I just pass that column, I just transform it, and now my data is scaled into a smaller format so that my model could understand it better. The next thing we have to do is we have to split our data. I'm splitting my data into dependent and independent variables. The very first, this is the independent variables. In that I have dropped the is promoted column, and why in the is promoted column I have gained the is promoted column. Next thing what I'll do, I'll just split my data into train test data. If I want to see the shape, how my data is splitted. So this is my trip 37,000. The next train shape test shape is 9,000. Around 80-20 ratio is taken. So my data is now perfectly well and ready for my model development phase, which I'll be doing in the next section. Hello all, welcome to the next section of this project, that is the model development part. In the previous section we have analyzed our data, we have processed our data, splitted our data. Now it's time to build our model using machine learning techniques. So we'll be using the following models. First is the decision tree classifier, second is the random forest, third is the sorry, the spelling is right, it should be logistic TIC, logistic regression. Now the very first thing we'll do, what we'll do in that, we have in order to check the accuracy, we have to continuously write the same code one again and again. So what I'll do, I'll just define a function which will automatically find out all the scores for me. For that, first I have to import all of these matrix library, that accuracy score, ROC score, recall score, precision score, confusion matrix, F1 score. Basically all of these things are required to validate or to check my class data for my classification problem. Okay, so now I am defining my matrix get CLF evaluation. I am taking, okay, plot my confusion matrix, plot my accuracy score, plot my precision score, recall score, F1 score, print all of these things. So whenever I'll pass this function, I don't have to write all the things, it will automatically give all of these things. Now I am just importing all of my models, standard scalar to basically to scale, logistic regression, decision tree, random forest. The very first model is my decision tree. I hope you are familiar with decision tree. What is that is it basically a collection of trees which splits our data into different probabilities. So you can have a look at decision tree documentation to understand it better. We'll not understand it into depth here. I will see that how we can implement it. We'll just define our model, then we'll fit our data with the X-trained data. We'll see that, okay, predict my data with the test data and predict my probabilities. Then I'll just pass this function. It will give me all of these things. It will provide me all of these things. As you can see, it is saying confusion method. Oh, okay, I have not defined this. Now I'll define it, then I'll just pass this. Okay, now see, as you can see, confusion matrix is this. It is giving me accuracy, precision, recall, F1 and AUC. Accuracy is 88%, precision is this. Now as see, I didn't have to write much of a code. I defined a function, I'm just passing this function. It is providing me the details. So this is my precision recall curve. Okay, this is my recall, this is my precision from my test data which I have taken. So this is my model validated or scored, which means I have around 88% accuracy for decision tree. The next model which I am doing is a logistic regression. Now if we'll define my model, predict my model by fitting it by the trained data and predicting with the text data, the same function which I will do again. In that it is performed with a very good accuracy around 94% and precision about 94. Okay, so that means my logistic regression is performed very well. This is my precision recall curve. As you can see, it is quite good. Okay, it is quite good, and how my precision is recall is going with a 94% accuracy. So but which means that my logistic regression is performing better. Now the next we'll see is random forest. We'll define a model. We'll see that, okay, how a random forest is performing. So now it may take some time, okay, because random forest, I hope you know what random forest is. So random forest is basically a collection of number of decision trees which work same in the concept of Gini impurity. It is also giving us a 94% logistic regression, also giving us a 94% data. In that, recall is 92%. Oh, precision is 92%, recall is 67% for that also. So logistic regression and random forest are equally performing the same. Okay, the plot of ROC curve, oh, precision recall curve is also the same for that. So now what we did, okay, what we did here, we just simply defined a function for the validation part of the checking accuracy. We defined a model and we didn't do any of the accuracy validation hyper tuning part or any of that sort. We can do that. We can use grid search CV or randomized search CV to hyper tune our model, see different parameters. But our main goal is to see all of these things, do all of these things with the help of automated library, that is the Eval ML. So now see that with this line amount of code, I am only able to attain this accuracy, which is good, but I can do more. So we'll do all of these things and see we can do all of these things with the help of automated machine learning library, that is the Eval ML, in the next section. Hello all, welcome to the final section of this project, that is the building our model using the automated machine learning. So now in the previous section, to summarize all of it, what we have done, we have taken the data, imported our data, we have analyzed our data, we saw how different attributes were dependent, we saw the correlation of this data, then we processed our data on the different categories, we standardized our data, we did one hot encoding on our data, then we build our model using the machine learning, logistic regression, random forest and decision tree. In that we saw that logistic regression and random forest performed quite good. We could have also done the hyper tuning, but we have not done yet. You can do that also, but now the aim is to see all of these things in the automated machine learning library. I have already given you an introduction what automated ML is in the introduction section. The Eval ML is, so a little about Eval ML, that Eval ML is an open source auto ML library which is written in Python that automates a large part of the machine learning process. We can easily evaluate which machine learning pipeline works better. So now you'll see that EvalML can provide you the full pipeline to see that okay which works better. That is a pretty good thing. So now the very first thing is you have to install EvalML. Now if you want to install it right in your local environment, that is the Jupyter or Colab, you can simply write pip install EvalML with an exclamation mark. It will install all the libraries, but in this I have already installed all of these. So first it will install, then it will uninstall all of these libraries because I have already installed it. So the one more thing which can happen, the one more thing which can happen to your thing is this might install the wrong version of sklearn, or your computer might have the wrong version of sklearn in order to run evalml. So what you do in order to safety, in order to make sure, you just write this command also so that it will update the best version suitable for evalml. Pip install pip install as scikit-learn this 0.24 version. Okay, so now it will just install all of these things. So but make sure when you install all of these you restart your runtime, because unless and until if you not restart your runtime, your collab environment will not read it. What happens is when you restart your runtime, will automatically again read all of this data. It again reads all of these data, then take all the problem, then take the data. So that is why it is important, to restart the runtime. So it is, as you can see, it is taking some time. Why it is taking some time? Because I have already installed it. Then what it did, it installed all the libraries. In order, I did this only to show you. So it installed all those libraries, but then it found that okay, these libraries are already present. So then it again installed all of them. Then it is again installing, uninstalling all of these because they are already present. But again I have to restart the runtime for that sake also. But we'll just wait for a minute so that it can perform the operation. So the by the way, till that, the next thing what we'll do is we'll import evalml. Then we'll see what are the problem types available. Basically, there are four problem types. The binary, that is the classification which we'll be doing between two variables, one or zero. Second is the continuous. Then third is the multi-class. The other is I think the time series binary. Okay. So now it is completely done. Then now it is installing scikit-learn. Okay, as you can see, found already installed. Now we'll just restart the runtime. We'll say restart the runtime for both the things. Runtime has restarted. Now we can import our eval image. It will take a minute. Okay, as you can see, your eval image is imported. If you would have not restarted the runtime, it would have provided me with an error. Now, if I want to see what are the problem types available, there are binary, multi-class regression, then time series regression, binary, time, multi-class. Time series basically the forecasting data, which changes continuously with time. This data is constant and is binary. Then we'll just split our data. We'll take the x and y, the same data which we processed. So we'll just go again in the up, and as we restarted the runtime, so we again have to execute all of these things. We just have to do, it will take a minute. I'll just execute the things which was required. We don't need to plot any of the things again. We'll just do the log transformation again. We'll do the one hot encoding for this. We'll split our data into x and y. Okay, so now X and Y is ready. We'll provide this data into our evalml. I am saying X train Y train eval dot pre-processing dot split. What it'll do, basically I did not need to do any pre-processing also. I could have easily splitted my data into X and Y given to this, but we have already done it. So why we should pass the same data only. So I have passed the same X and Y data. It's split it into X train X test. We write this command evalml dot pre-processing dot split data. This is the command required to split the data. Now what we'll do, we'll run this command. I am saying from evalml.automl import automl search. This is what you have to import in order to train your data. I am defining automl search. I am giving my data x train y train. I am selecting my binary type, that is my problem type, that is binary. And I am saying automl.search. What automl.search will do, it will search all of these models. It will compare all the models, and it will see that okay, which model is the best. Then what I'll do, I'm saying AutoML.rankings. That will it will provide me a table or a leaderboard for which will tell us okay which model performs the best. When I'm saying I'll be saying I'll store it into best pipeline. When I'm saying I'll say that okay describe that pipeline from me. Then I'll just finally predict the results from it. Okay, on predicting results, I can also see the EVA level objectives. Objectives basically, objectives are the accuracies. Okay, in what suppose I have taken here accuracy dot binary, which means that give me those model, give me the best score in that the accuracy binary score is highest. So now it is automatically searched. The rankings are these. The light GBM is the highest with that the highest score percentage rather than baseline 92% score. These are the parameters. Now if I want to store my best pipeline, I can describe okay what is my I can describe what is my best performing model. So this is my light GBM classifier. Imputer is given, like all the classification, what are the parameters are taken, training data, all the things which were taken, log loss, binary score, Guinea impurity, AUC precision, F1 score. All of these things are provided. It's a very detailed analysis of a model. Okay, you cannot provide this. I see why I have to write a whole function in the ML part in order to take only one of few of these information. But in Eval ML, all of these things are provided with a single line of code. Now, if I see what are the objectives which I can give, I can take all of these things based on my classification problem. If it is a binary or a regression, I can pass that accuracy and it will provide me the score for that. As you can see, my binary score is around 94%. With that model I can hypertune this with the simple amount of code, but I'm not doing that. You can see the documentation of UML how to hypertune. You just have to write a simple amount of one line code, hypertune.model. It will hypertune your model. Now we can load your model into pickle file also in if you want to deploy your model. Okay, so I'm not deploying your model, I've just stored it. Now if I'll predict my model, I'm saying model.predict xtest. Okay, I'll just predict my model. So this is my prediction. If I want to see my predictions, so this is my predictions. Okay, if it is 0, that means it should not be promoted. It is 1, that means it should be promoted. This is my y-test data. You can compare both the data and see okay how the data is distributed. So now this was about all about EvalML. How you can do, you can visit their website and have a look at their documentation to know more about it. This slide, this documentation, this notebook and data I'll be providing to you. Then you can see that you can make new projects with this knowledge and you can implement this on your own also. Thank you. Happy learning.